In this video, we are going to go over the properties of various parent functions. Now, in class earlier, we went over the properties of f of x equals x squared, which you can see right here. And we are going to continue for a number of other functions, graphing those functions, finding their domain and range, their intercepts, deciding whether it's an even, odd, or odd function, or perhaps it's neither. Now, what intervals is that function increasing or decreasing, and what are the minima and maxima of that function? We'll start with the square root of x. To make our life a little bit easier, we are going to be using Desmos to graph many of these functions. So we'll start with the square root of x. In the square root of x, the graph looks something like this. Let's just copy and paste this. And let's figure out what is the domain and range. I like to add a small arrow here just so I remember that this is going up and to the right. So my domain, what are all the possible x values? Notice that my graph really starts at this point right here, which is 0, 0. Another important point on this graph is 1, 1. And I guess another important point would be 4, 2. It's good to know 2 or 3 important points on each graph. So let's think about what's the domain. The possible x values, the smallest x value is 0. And 0 is part of our domain, so we'll do bracket, square bracket 0. And it keeps going to infinity, right? You can plug any positive number into the square root function and you will get an output. So my domain is from 0 to infinity. And similarly, my range, right, my smallest y value is also 0. And again, even though it's getting bigger, even though it's barely pointed up, it will continue to go in that direction off to infinity. And so no matter how large a number you can think of, you can always find an even larger number that when you take the square root, it will be equal to that number. So the square root function, you can have an output as large as you would like. So my range is from 0 to infinity. What are the intercepts? Well, the only place that this graph touches either the x-axis or the y-axis is right here at that point. And at that point, it actually touches both. So my x-intercept is 0, 0, and my y-intercept is 0, 0. By the way, you could also say the x-intercept is 0 and the y-intercept is 0 in this case. What I'm saying is the x-intercept and the y-intercept could be expressed as points or just the value. Like, for example, the x-intercept would be the x value of that point. So you could say the x-intercept is 0. All right, is this even, odd, or neither? Looking at this graph, it does not look like it's symmetric over the y-axis, so it's not even, and it does not look like it has symmetry over the origin, so it's not odd, so this is neither odd nor even. On what intervals is f of x increasing or decreasing? Well, as x increases, the y value continues to increase, right? If we look at this as I go left to right, my y value is just going to keep getting bigger and bigger. So from the very beginning of this function until the very end, it is increasing. So it's increasing. The beginning of this function in terms of x values is 0. So starting at x equals 0 all the way to x equals infinity, it is constantly increasing. And it is never increasing, never decreasing. All right, are there any local maxima or minima? There is no maximum. There's no absolute maximum. I don't see any hills or valleys. However, there is a minimum value, right? The smallest y value, again, happens right here. So there is an absolute minimum at 0, 0 equal to 0. Okay, so the absolute maximum minimum happens at the point 0, 0, and the absolute minimum of this function is equal to 0. That's the smallest possible y value. There is no absolute or local maximum, and there is no local minima. Okay, and that is the square root function. Let's move on to a new function. We'll do x to the third. And let's graph this. Here's our graph. I'm going to go ahead and copy and paste that over to our OneNote. And again, I like to add my arrows just so I remember that it's, in this case, the function keeps going up and to the right and down and to the left onto infinity. All right. So let's discuss what is the domain and range. The domain, again, if you think about it, you can plug in any negative number, any positive number, or 0 into the function f of x equals x to the third. This graph will keep going further and further to the left and further to the right if I zoom out. So my domain is all real numbers, which we express as negative infinity to infinity. My range, it's very clear that my y values go up into positive infinity and down into negative infinity. So my range is negative infinity to infinity. My intercepts, where does it cross the x and or y axis? Just like the before, it crosses both at one point, which is at 0, 0. And by the way, some of the important points in this function, I would say, are 0, 0, 1, 1, and negative 1, 1. If you can remember those 3 points, those are the 3 most important points. So our intercepts, again, is 0, 0. The y-intercept is also 0, 0. Is it odd or even or neither? It appears that this has symmetry around the origin. If I rotated this graph 180 degrees, it would line up with itself perfectly. So this is an odd function. All right, when is it increasing? When is it decreasing? As I go left to right, notice, and I'll just highlight it. I'll start at the very bottom left. As I go left to right, it is constantly increasing. So I would say that it is increasing on negative infinity to infinity. It is constantly increasing. Now, there's a possibility that maybe you don't include the point 0, 0 because it's flat for one moment. You could make that argument if you wanted to. I think it's easier to just think this is increasing from negative infinity to infinity. Different textbooks might tell you slightly different answers on that one. And it is not decreasing. Or I should say never decreasing. All right, maxima and minima. There is no absolute max. There is no absolute min. It keeps going to infinity. And we don't really have any hills or valleys either. We've got this kind of funny point right there, but that's not really a local maximum or a local minimum. It's not quite a hill or a valley. It's something different, right? All the points to the left of that point are smaller, but all the points to the right of it are larger, so it can't be a local maximum or a local minima. So there are no local or absolute maxima or minima. All right, so that's x to the third. Let's do the cube root of x. All right, let's go back to Desmos and let's graph the cube root of x. By the way, I'm not sure how to enter the cube root in Desmos, but one trick is the cube root of x is the same as x to the 1/3. Similar to how the square root of x is equal to x to the 1/2. All right, so let's go ahead and grab this graph. And one thing I want you to notice is that the graph of the cube root of x is really basically a rotation, and I would say maybe even a reflection. It looks like it's like a sideways version of the graph of x to the third, which is normal. If you think about it, that should make some sense. And when we talk about inverse functions, you will see that there's a reason for that. Okay. Domain and range. Okay, very similar to x to the third. My domain, I can plug in, you can see that this is going to go to negative infinity and positive infinity on the x-axis. So it's all real numbers. And my range, even though it's growing fairly slowly, it's going to just keep growing and keep going up and up and up until infinity as well. And same in the negative infinite direction. So my range, it could be any real number. So my range is from negative infinity to infinity. My intercepts, again, will be here at 0, 0. And again, The important 3 points here are 0, 0, -1, -1, and 1, 1. By the way, I think I made a mistake up here. This was supposed to be -1, comma, -1 up here. So I made a small error. Hopefully you realize I got it wrong. It happens sometimes. All right. So my x-intercept is at 0, 0. My y-intercept is at 0, 0 as well. Is it odd or even? Just like x to the third, you can tell that this is has rotation over the origin. If I rotate it 180 degrees with the center at the origin, it would line up with itself exactly. So this is an odd function. All right, what intervals is it increasing? It's really increasing again. No matter where I start, once I start all the way at the left, it just keeps getting bigger and bigger. So let's actually write that out. So this is increasing on the interval -infinity to infinity. So in other words, it's constantly increasing and it never decreases. The maxima and the minima, again, there is no absolute maximum or no absolute minimum. It keeps getting, my y values continue to go all the way up to positive infinity and all the way down to negative infinity. And again, we don't have any hills or valleys in this graph. So there are no local or absolute maxima or minima. All right, and we are done with x to the third. All right, let's do the square root of x. I'm sorry, I said square root of x, and I meant to say the absolute value of x. So we'll put that in our calculator. Let's put this here. And let's copy and paste this. Okay. We'll start with the domain and range. My domain, my x values, you can see that this graph would keep going to infinity on the left and to negative infinity on the left and positive infinity on the right, along the going left or right, the x values. So our domain, my possible x values, you could do anything from negative infinity to positive infinity. And that should make sense. Remember, the absolute value just says you take any number you want, you plug it into the absolute value, and it kind of spits out the positive version of that number. Or in the case of 0, the absolute value of 0 is equal to 0. Remember, the way we think of absolute value, it is the distance from the origin, from 0. The range is different. It does go to positive infinity. You can tell that it's going to keep getting bigger and bigger. The bigger the x value that we plug in, the bigger the y value. But there is a minimum, which happens right here at the point 0, 0. And again, my important points, I would say, are these 3. So there is a smallest y value, and it's equal to 0. And I want to put a square bracket because 0 is a number that is a possible output of this function, and it goes all the way to positive infinity. The intercepts, again, this graph intercepts both the x-axis and the y-axis at 0, 0. So the x-intercepts are 0, 0. The x-intercept is 0, 0. And the y-intercept is 0, 0. Is it odd, even, or neither? Hopefully you can see that this does have symmetry across the y-axis, which means that this is an even function. All right, when is it increasing? When is it decreasing? If I go left to right, you can see that it is decreasing for all x values until we get to x equals 0. So we will say that it is decreasing, and starting at negative infinity. So all the way as far left as you can go, it's always decreasing until we reach 0. At which point, after that, if I go left to right, my y values start to increase. So it's increasing on 0, infinity. All right, last, let's do maxima and minima. Is there any absolute maximum? There is no absolute maximum. The y values keep getting bigger and bigger. So there's no absolute or local maxima. I don't see any hill in this case. There is a valley, however, right? In fact, now my valley is more of a V than a U, but that's okay. So there is a, right? So we do have a local maximum or local minimum at 0, 0. And that is also the absolute minimum, right? The smallest possible y value is also 0. So there is a local minimum of, or at 0, 0 equal to 0, and there is an absolute minimum at 0, 0 equal to 0. All right, so that is the absolute value function. We're going to do one more function, which is 1 over x. All right, so 1 over x looks something like this. Now, this is an interesting function, a little bit different than some of the others. Domain and range. Well, one thing that I want you to, let's just note at the very beginning that this function has two asymptotes. The graph gets closer and closer to the x-axis, but it never crosses the x-axis. And similarly, it gets closer and closer to the y-axis, but never touches it. Okay? Now what that means is that for my x values, it can be really any x value going to negative infinity and going all the way to positive infinity, but it can't be 0, right? And that should make sense. You can't do 1 divided by 0. That is not allowed. You are not allowed to divide by 0. So it's going to be all x. My domain will be all real numbers except for 0. Now, in interval notation, it's a little bit more complicated to write this, but it's not too bad. We just, again, I'm just going to do a quick graph. Here's negative infinity, here's infinity, and I want to include all the numbers, but I want to skip 0. So I don't want to count 0, but everything to the left of 0 is in my domain, and everything to the right of 0 is in my domain. So that means that there's basically 2 intervals. All of the points, all the numbers less than 0 and all the numbers greater than 0. So first I'll do the left-hand side. The left-hand side is all the numbers in between negative infinity and 0. That's this left-hand side. And I put that together using the union symbol with all the numbers to the right of 0, which would be in between 0 and infinity. Let's look at the y values. The y values, too, if you notice, it can be any y value, but it can't be 0. Because 1 divided by a number, that can never be, no matter how big the number is, it can never be equal to 0. That would be impossible. Think about it. 1 divided by 1,000,000 is going to be a very small decimal, but it's never going to be 0. No matter how big I choose x to be, I'll never get 1 divided by x equal to 0. So similarly, my range is all real numbers except for 0, and so I'll just express that only in interval notation, and it will be the exact same as the range. Let's see, what are my important points here? I would say this point, which is -1 comma -1, and 1 comma 1. And let's just do at least 2 more. Let's do, I would say 2 comma 1/2, and this would be 1/2 comma 2. Similarly, we would have this point right here would be -2 comma -1/2, and -1 1/2. I think really the important ones, if you are really these two, if you can just remember those, I would say that would be the most important ones to memorize. All right, the intercepts of f of x. Well, as we said at the very beginning, this graph never crosses the x-axis and it never crosses the y-axis, so there are no intercepts. Is it odd, even, or neither? Hopefully you can see there is some symmetry here. It is a rotational symmetry, right? If you rotate this graph and with the center of rotation at the origin, and you rotate it 180 degrees, you will get the same exact graph. It will line up with itself. And so this is an odd function. All right, on what intervals is f of x increasing or decreasing? I'm going to get rid of some of this stuff so we can see a little bit easier what we're dealing with. All right. All right, let's go from left to right here. If I go from left to right here, it is getting smaller and smaller on the left-hand part. And then if I go left to right starting at the second part of this, again, I'm getting smaller and smaller as I go left to right. So in both, I would say almost halves of this, on both parts of this graph, As the x value increases, my y value is always decreasing. Now, to express this, you have to be a little careful, because what are the intervals on which it's increasing? Well, the left-hand part, which I guess would be this part, that's the interval. So this is decreasing on negative infinity to 0. That's the left-hand part of this graph. And it's also decreasing on the right-hand part of this graph, and that's for the x values in between 0 and infinity. So it's really decreasing on its entire domain, which is this up here. And it is never increasing. As x gets bigger, y gets smaller for the entire, no matter what x values we are talking about. All right, what are the minima and the maxima? Again, the x value obviously goes up to, or the y value obviously goes up to infinity, and it goes down to negative infinity, so there's no absolute maximum or absolute minimum. And notice we don't have any hills or valleys here either. So there are no local or absolute maxima or minima. And we are done. All right, so these are some very basic functions that are very important to understand and to know very well as we continue to learn in college algebra. These are the basic functions you need to master in order to understand slightly more complicated functions. Many of the functions that we're going to be talking about, these functions are the basis of those functions. All right, with that being said, I hope this video was helpful, and we will see you in the next one.